Example 3. Company ABC just announced that it'll cut its dividend from $4.5 to $3.1 per share and use the extra funds to expand. Prior to the announcement, ABC's dividends were expected to grow at a 4% rate, and its share price was $55. With the new expansion, the dividend growth rate is now at 5.6% per year. What share price would you expect after the announcement? And is the expansion a positive NPV investment? Okay. So for this problem, we're gonna draw two timelines. Okay. One before the announcement, and another one for after the announcement. So it says, before the announcement, the dividend was $4.5 per share, and after the announcement, it'll be 3.1 per share. Okay? And the dividends growth rates also change. ABC's dividends were expected to grow at a 4% rate prior to the announcement. So 4.5 times 1.04, 4.5 times 1.04 to the second power, and so on. Okay. And after the announcement, the dividend growth rate is now at 5.6% per year. So 3.1 times 1.056, 3.1 times 1.056 squared. Okay. And it also says the share price before the announcement was $55. Okay. And we're trying to solve for the share price after the announcement. So what is the share price after the announcement? Okay. So we're gonna think backwards here. So we're trying to figure out the price of the share after the announcement, right? But we know we have the dividend information, 3.1 in year 1, and it grows at 5.6% forever. Okay. But in order to calculate the share price, we need to first figure out the R. What is the R? Right? It's not given. So we can figure out the R from the previous timeline, the timeline for before the announcement. Okay. Here we have the share price, and we have all of the dividend information, 4.5, that grows at 4% per year, goes on forever. So from this, we can figure out the missing piece. Okay, so we'll do that first. So the first step, let's write it here. Calculate the R, the discount rate, from the before timeline. Okay, so the share price of $55 represents the present value of all of the dividends. Okay, so this price at time 0 of $55 is the present value of all of the future dividends. Okay, so we're gonna look at the cash flow pattern, and we can see that this cash flow is a growing perpetuity. We have dividends occurring every year, and it's growing at a constant rate, 4%, and it's going on forever. So it's a growing perpetuity. So the present value of the dividends we can use PVGP formula, present value of a growing perpetuity, right? So the formula for a growing perpetuity, PVGP, is cash flow 1. In this case, the first cash flow occurs in year 1, so there's no additional step, right? We immediately get the value as of time 0, R minus G. So the first cash flow is 4.5. The R is missing. We're trying to solve for R. And the G is 4%, the growth rate. So we can simplify this long equality. We can say this $55, the share price, is equal to this expression. Okay? And then we'll use algebra to figure out what R is. Over R minus 0.04. So we're trying to solve for R. We'll go step by step. We can multiply both sides by R minus 0.04. So this is to get the R, the thing that we're trying to solve for, out of the denominator. Okay, so we multiply both sides by R minus 0.04. So on the left, we have 55 times R minus 0.04. On the right, we have 4.5. And then we're going to divide both sides by 55. So we have R minus 0.04 equals 4.5 over 55. And then we'll add 0.04 on both sides. So we have, we'll do it here. R is equal to 4.5 divided by 55 plus 0.04. So R is 12.18%. Okay. Again, what we just did is we know that the share price is $50, and that's the present value of the dividends. And this dividend, if you look at the before timeline, the dividend is in the form of a growing perpetuity. So we're going to use the PVGP formula. So we have 55 equals this 4.5 over R minus 0.04. And then we use algebra to solve for R. Okay. Now we know the R. Okay, so it's no longer unknown. R is 12.18%. Okay. So we're going to use the same R and then use it on the second timeline. So we're implicitly assuming that the announcement doesn't really change the riskiness of firm ABC. Okay. If the risk of the firm changed, then the R's should change. Okay, so that's not the case here. So now the second step is pretty straightforward. We have this timeline, the after timeline, and we have all the components we need to figure out the price. We're still dealing with a growing perpetuity, but we have different numbers now. 3.1 occurring in year 1, and it grows at 5.6% every year, and the discount rate, the cost of capital, cost of equity, is 12.18%. Okay. So I'm going to come down here. The P, price at time 0, is still, present value of all of the dividends, right? And it just happens that we have another growing perpetuity. PVGP as of time 0 is the cash flow that occurs in year 1 minus R minus G. The cash flow is 3.1. R is 12.18. And then the new G is 5.6%. So if you do the math, P0, the new P0 is $47.10.